Good morning, class. We are looking at section 4.5, summary of curve sketching. Okay, so to do that, let's remind everybody of absolute extrema that we have seen before. It refers to the entire domain, the largest y coordinate and the smallest. That's for absolute, also known as global. For local or relative, it happens in some open interval. A critical point simply means find f prime, okay, and where f prime is 0 or doesn't exist, those are critical points. And the closed interval theorem, you have a function, you have to show it's a continuous function, and then it's continuous from A to B. You evaluate the function at its endpoints and critical points. The largest is an absolute max, the smallest is an absolute mean. The Rolle's theorem and the mean value theorem, the function has to be continuous in a closed interval, differentiable in an open interval. If f of a equals f of b, then f prime of c must be 0 somewhere in between. That's the Rolle's theorem. If not, there is a number in between such that f prime of c equals f of b minus f of a over b minus a, and Rolle's theorem is a special case of the mean value theorem. This is the summary of how derivative affect the shape of a graph. Okay, increasing, decreasing, concave up, concave down, inflection point. Okay, and the summary of curve sketching, in short, you use pre-calculus and you add to it the information from calculus by finding local extrema and intervals of increasing, decreasing, concave up, concave down, inflection point, and the graph looks better. We also looked at L'Hopital's rule, okay, that when you come up with the indeterminate form of 0 over 0 or infinity over infinity, you can use L'Hopital's rule, okay? That means the limit of f of x over g of x as x approaches a, it's the same as the limit of f prime over g prime as x approaches a. Now, if you have other indeterminate forms such as 0 times infinity, infinity minus infinity, 0 to the power of 0, 1 to the power of infinity, infinity to the power of 0, you must make them look like one of those formats so you can use them. That's extremely important, okay? So as long as we have that, we can use L'Hopital's rule. All right. All right, now summary of curve sketching as far as this section is concerned, just quickly. Okay. When we are looking at a rational function, and you have seen that before, class, just in like any other function, can we come up with intercepts? Can we come up with the domain? And then we add to it. We add to it vertical asymptotes. Vertical asymptotes, and we can stick with the method that we learned. We set the denominator equal to 0. As far as definition is concerned, vertical asymptote has a specific definition in calculus, and that means the limit of a function when x approaches a number such as a is either negative or positive infinity, and it doesn't matter, it's a from the left or right, okay? Then x equals a becomes your vertical asymptote, okay? The graph of a function never crosses a vertical asymptote. It may intersect it, and VA, by the way, it is important to put the function in its simplified form in lowest term, because if there's a common factor between the top and the bottom, that doesn't mean if you set the denominator equal to 0, it gives you a vertical asymptote, okay? Now, also, this is important. The graph may or may not cross the horizontal asymptote. So one of the things that you have to do, first of all, the definition is really the concept of the end behavior. What is the limit of f of x? As x approaches positive or negative infinity, if it's L, okay, then y equals L is the horizontal asymptote. And you set the function equal to that to see if it crosses it or not, okay? Horizontal asymptotes occur when the degree of the numerator is less than or equal to the degree of the denominator. Now, I'm sure you remember the concept in pre-calculus that we look at the degree of the numerator and denominator and we make a decision. I will just quickly remind you of that in a moment. Finally, we also have what's called a slant asymptote. Slant asymptote is when the degree of the numerator is larger by 1, you do the long division, okay? And a specific definition of that is that the limit of f of x as x approaches positive, negative, infinity, instead of a number, if it's a number, it's a horizontal asymptote. If it's a linear function such as mx plus b, we say slant asymptote, also known as oblique asymptote, is y equals mx plus b. And when would that happen? Take a look at this simple example. The difference in degree must be 1. So that's when the slant asymptote occurs. Now, to summarize this just quickly, if we happen to have, let's do this class. Okay, let's, if we happen to have y equals, okay, a to the power of m, I'm sorry, a sub m, x to the power of m, I'm looking at the leading term only, over b sub n x to the power of n all the way to the n, okay? So let's see what happens. Case number 1, m is less than n, we have horizontal asymptote y equals 0. Case number 2, m is equal to n. We have a horizontal asymptote y equals a sub m over b sub n. That means the leading coefficient take over. Number 3, m is precisely n plus 1. Then we have slant asymptote or oblique asymptote, and we find it by long division or maybe sometimes synthetic division. So I hope everybody is comfortable with the concept. So how do you find the asymptotes, horizontal asymptotes, where slant asymptotes is fairly straightforward. How do you find the vertical asymptotes? Even if you don't go with the definition in calculus, you set the denominator equal to 0, that's fine, but it is important to see there is a specific definition. So again, this would be the definition of slant asymptote. All right. Again, remember the horizontal asymptote and the definition that we learned previously, okay? Horizontal asymptote is the limit of f of x as x approaches plus minus infinity equals L. That means y equals 0. So that's, and then we have a definition of a vertical asymptote, okay, from before, okay, vertical asymptote, horizontal asymptote. I'm just refreshing your memory. All right. We want to find all the asymptotes here, class. So first, let me explain it fairly fast, nice and easy in the following manner. If you want to go with the pre-calculus, it's okay. I hope you see that. If you want to go with the pre-calculus, this is how fast we can get this. You set the denominator equal to 0. That means x equals negative 2/3, okay? That's 1, and x equals a negative 6/5. Those are the vertical asymptotes. Done. Then you want horizontal asymptotes. If you notice, the top becomes 2x squared, doesn't matter what the rest is, and the bottom becomes 3 times 5, 15x squared. So y equals 2/15. is your horizontal asymptote, there is no slant asymptote. This is a quick version of doing that. Now, vertical asymptote denominator is 0, find the answers. And if you want to stick with the formula, which says the definition that says vertical asymptote, look at the bottom, vertical asymptote x equals a. If the limit of f of x as x approaches a from the left is negative infinity or positive infinity, so on and so on. You just set the denominator equal to 0, and that's fine. As far as the horizontal asymptote, you really don't have to, if you want to look at a quick answer, you don't have to multiply the whole thing. If you just realize the leading term is 2x squared for the numerator, 15x squared for the denominator, 2 over 15 is the answer. The only justification I expect, just write down y, because the degree of the top equals to the degree of the bottom equals 2. Okay. If you take this, really the process is what you see. I hope you see that. By the way, negative or positive makes no difference, and it makes it 2 over 15. And that is the horizontal asymptote. There is no slant asymptote. Again, if just right here, you say horizontal asymptote y equals 2 over 15, then you have to write down because the degree of the numerator equals to the degree of the denominator, and both of them are equal to 2. That's the reason. However, what you can see is the proper procedure. And by the way, if it's positive or negative infinity, they both result in the same thing. Because the process, if you recall, when we found the limits, the process was what? When x approaches infinity or negative infinity. If you end up with infinity over infinity, one technique was to divide the top and the bottom by the highest degree term in the denominator, okay? And that would do the job. Okay. Now, can you, if it's infinity over infinity, can you use L'Hopital's rule? Yeah, you can use the L'Hopital's rule and observe also if you like. You see that you end up with the same. In fact, that'd be interesting if you try to do it by that. All right. Determine the vertical and horizontal asymptotes. Again, it's fairly easy to see. Vertical asymptotes. Okay, this is the definition. Set the denominator equal to 0. Okay. And so before you do that, notice there is a common denominator of x. Common factor of x, my apologies. If you don't drop the x, class, if you don't drop the x, you may be under the assumption x equals 0 is a vertical asymptote, where it's not. The function is not defined at x equals 0. In other words, the fact that x is in the denominator, it gives you the same domain, meaning you have to exclude 0, 1, and -1. So this does affect the domain. There is no question about that. However, it doesn't give you a vertical asymptote. What does it give you? At x equals 0, it gives you a hole. So first drop the x. And now the vertical asymptote becomes x equals 1, x equals -1. And the horizontal asymptote, obviously, the degree of the numerator is 1, the degree of the denominator is 2. That's why it becomes 0. Class, I hope you understand why this is 0. Degree for the top is 1. Degree for the bottom is larger. Doesn't matter by how many. Okay? The fact that is okay. Everybody can hear me, class?
Yeah.
I think there was a glitch in the internet and it got, I think, disconnected on my end. But anyways, so I hope everybody's clear. Again, what is the effect of this. This generates a hole at x equals 0 because the function is not defined there, which means basically you put it in here, okay? You put it in here. So what do we get? We get -2 at top and then -1 or 2 at the bottom. So this is the location of a hole. Okay, so I want to make sure we understand. You plug in 0 in the simplified version, and that gives you the pair at x equals 0. In this case, you factor out the denominator, x equals 0, x equals -4, x equals +4. Those are vertical asymptotes. The degree of the numerator is 0. The degree of the denominator is 3. Therefore, the horizontal asymptote y equals 0. Again, a short version, a fast version is just as good. Okay, everybody? Vertical asymptotes, horizontal asymptotes. Again, vertical asymptote is very fast. X minus 1 is 0, x equals 1. That's your vertical asymptote. Okay. Horizontal asymptote. Well, we don't have any. Why not? Degree of the numerator is larger than the degree of the denominator. No horizontal asymptote. Slant asymptote. Look at the degree. The top, the degree is 2. The bottom is 1. There is only a difference of 1. Therefore, yes, there is. I'm going to assume you can do the division, long division or synthetic division. It's up to you. Okay, so first of all, vertical asymptote x equals 1, horizontal asymptote, we don't have any. So you go through the long division, okay, and your quotient is x plus 1, and your remainder is -3. Again, I'm assuming everybody can do long division or synthetic division, okay, class? And so, and the reason I say long division is probably more important because not always you can do synthetic division. You can do it if it's of degree 1, the denominator, okay? And so long division, and this is obviously degree 1. So y equals this piece is your slant or oblique asymptote. Y equals x plus 1. So one more time. You want to find all asymptotes. Denominator is 0 is your vertical asymptote. Horizontal asymptote doesn't exist because of the degree difference. The only time you have horizontal asymptote if they have the same degree, the top and the bottom, or the degree of the numerator is less than the degree of the denominator, in which case y equals 0 becomes a horizontal asymptote. Slant asymptote, long division gave us the answer. All right. We want to find the asymptotes. Again, one easy way, you vertical asymptote, you set the denominator equal to 0, factor, then find out. Horizontal asymptote, degree of the top and the bottom are both 2, so 2/3. Y equals 2/3. It's important to write the equation, okay? So take a limit or just write down horizontal asymptote equals y equals 2/3 because the degree of the top and the bottom are the same. Remember, the process of limit was to divide by x squared. I hope you remember that. Or as I said, you can even do, now you can do L'Hopital's rule. As far as VA, short for vertical asymptote, you can factor the denominator into 3x minus 1 times x plus 1. This gives you x equals 1/3. This gives you x equals -1. And therefore, you have 2 vertical asymptotes. Okay. I've been going over this fast, and I know that class, but I hope you all remember it from college algebra as well as pre-calculus. So there's really nothing brand new here. The only thing we are adding, the definition from calculus. Before I look at an example of a graph, Let's say we have the following situation. We have a function, let's say f of x or g of x or h of x. We have a vertical asymptote, x equals 1, x equals 3. Horizontal asymptote, y equals 1. We want to come up with the answer. So I hope you see there are infinitely many answers in essence, but just for the sake of argument, one answer, let's start with the vertical asymptotes. I hope you see that it becomes x minus 1 times x minus 3, right? Because those two will result in this. Okay, if horizontal asymptote y equals 1, that means the degree of the top must be the same as the degree of the bottom, and the leading coefficient must be the same. I hope you see the denominator is x squared minus 4x plus 3. So you need the x squared at top. Now, this is because horizontal asymptote is 1, okay? Now, can I have, I don't know, x squared plus 7? Yes. X squared minus 1? Yes. So that's why I said there are many different answers, okay? But this is one possibility. Many times they add other things like intercepts, and then it becomes a unique function. Again, is this the only answer? Absolutely not. Okay, is this the only answer? Absolutely not, just for the sake of argument. How about x squared plus 7? Okay, I just made it up, okay. All right, let's look at an example of a graph class. So how do we graph? Well, we use the information that we have from pre-calculus, okay. Asymptotes, intercepts, domains, and we add derivatives, the first and the second, to come up with extrema, inflection points, so on and so forth. And to be honest with you, by nature, taking the derivative is difficult because it's tedious. It takes long because you're dealing with the quotient rule. And so let's start with a simple example. Simply put, intercepts, I hope you realize, to find the x-intercept, you set y equal to 0 and y or f of x equals 0. That means the top equals 0, okay? And you get the answer. You find the y-intercept by setting x equal to 0, okay? So x-intercept is 1, 0, okay? So when y is 0, class, the top is 0, x becomes 1. The y-intercept, you replace the x with 0, they go away, so minus 1 over 1, okay? Asymptotes, vertical asymptotes, the denominator 2x plus 1 is 0, so x is negative 1/2. Horizontal asymptote, the degree of the top and the bottom are the same, so y equals 1 over 2. So vertical asymptote, set the denominator equal to 0. There you have it. Horizontal asymptote, y equals 1/2. Why is that? The degree of the numerator is 1. The degree of the denominator is 1. And this x at top means 1x, everybody. So 1/2, okay? And whenever you either have horizontal asymptote or slant asymptote. You can't have both. So there is no slant asymptote. So as far as the domain is concerned, okay, basically x can't be negative 1/2, class, okay? All right. So what else do we need? All right, let's differentiate this. Differentiation, we want to find f prime of x requires what? The quotient rule. So the derivative of the top is 1 times 2x plus 1 minus the derivative of the bottom is negative 2 times the top, x minus 1 over the bottom squared. So that's the horizontal asymptote. So derivatives and domain, the domain was mentioned. I mentioned X can't be negative 1/2 class. And by the way, let me also write let me also write the interval notation. Negative infinity, negative 1/2 union, negative 1/2 infinity. That would be the notation you use. Okay, everybody. And so here's the derivative again. The top gives you 1 times the bottom, minus the bottom gives you 2 times the top over the bottom squared. So I hope you see that this is minus 2x plus 1, okay. Plus 2, my apologies. Let me write it at top of it. So we have minus 2x minus times minus plus 2, okay. Which means 2x and minus 2x cancel each other. The numerator becomes 3. And I hope you see that because the numerator is a positive value and the bottom has exponent which is even, it doesn't matter 2 or 2000, this will always be increasing, however, not at x equals negative 1/2. So if you go with the sign graph and that, you can figure it out, or just right here, if you, for this is simple enough. You don't want to do the sign graph, you don't have to. But understand, you cannot say the function is increasing from negative to positive infinity. You can't say that. Okay, if it did, it would be a nice and smooth curve, everybody. Instead, it is from negative to negative infinity to negative 1/2, increasing, union from negative 1/2 to infinity. All right, and there is no extrema. We don't have anything. Okay, and so it's increasing from. As far as f double prime is concerned, to be honest with you, the easiest way to get that, by the way, let me just rewrite this at top of it. If you, maybe I use it, yeah, if you wrote this as 3 times 2x plus 1 to the power of minus 2, this is the easiest way to differentiate this, again, f double prime. So, okay, it would be what? 3 times negative 2 is negative 6, okay? The same thing to the power of negative 3 times the derivative of the inside, which is 2. And I hope you realize that gives you negative 12. And then 2x plus 1 to the power of negative 3 goes down, becomes cubed. And what's going on here, because this is cubed, then things do change. If it was even, you would just say it's always negative. So when you do the sign graph on that, to the left of negative 1/2, okay, first of all, add negative 1/2 is undefined, okay? To the left of negative 1/2, for example, put negative 1 becomes negative 1 cubed, which is negative. Negative over negative is positive. That's how you arrive at it. And to the right of it, the easiest number would be 0 if you plug in 0, but they alternate anyways, because this is odd. And so it's concave up here, okay, from negative infinity to negative 1/2, and concave down here from negative 1/2 to infinity, okay. There is one more important thing we need to do always. We have to set this function equal to the value of horizontal asymptote, which happen to be 1/2, and solve. I'm going to leave it for you to show that this doesn't give us any solution. It has no solutions, class. Set this equal, okay? In other words, set x minus 1 over 2x plus 1 and 1/2. Try to solve this and you see it doesn't give you anything. When you do the cross product, you get, what do you get? 1 equals negative 2, which is a false statement. So there is no way the graph crosses the horizontal asymptote. And here's what's interesting, class, and I want you to know that. On the right side, either the graph, okay, I don't want to, okay, I did that, so let me just use it. Either the graph looks like this or looks like that. And because you already have a couple of points on the right side, is clear. On the left side, it goes like this, or it goes like this. And you can pick up any pair on the left of your vertical asymptote, -1/2, for example, -1, okay? And plug it in and you'll see it goes like that. And like this is not to scale, but you get the picture again as an example. If you plug in, let's say, x equals -1, okay, then what do you get? -1 and -1 is -2, okay. -2 plus 1 is -1, you get 2, so you get -1, comma 2, okay. And so somewhere here, -1, comma 2.